everyone, it's my pleasure and honor to provide this video for Stay at Home with Software Engineering. It is a difficult time to all of us, but it also provides many chances, especially for digital innovation and software engineering. And an important aspect to benefit from these chances is to consider industry-academia collaboration. My name is Michael Felderer. I am a professor of software engineering at University of Innsbruck in Austria. My main research areas are in the context of software quality engineering, especially also with a focus on testing. I also work a lot with industry, so I have lots of experiences, and I also performed several empirical studies where we investigated aspects of industry-academia collaboration to further improve it. And this is exactly what I want to present to you today. So my talk is about evidence-based reflections on industry-academia collaboration in software engineering with a focus on software testing. So, what industry and academia, what is it about? So industry and academia first have different goals, right? So industry is interested in practical solutions, whereas the main output of academia are publications. Industry provides its innovations in disruptive innovation cycles, whereas academia normally has fixed innovation cycles that are, for instance, defined by the duration of a PhD thesis or by the duration of a research project. And finally, industry is goal-driven, whereas academia is curiosity-driven. This means for academia, topics may be of interest that are just curious, but have no immediate practical impact. But industry is always driven by this development innovation aspect that brings it further. Given this, there are several maturity models of closeness between industry and academia. Especially in the context of software engineering, industry and academia should work closely together, as this is a very practice-oriented field. But the lowest level of collaboration is level 1, that industry and academia are not in touch. A better level is at least when academia takes general challenges for its research, and another one if even the solutions are brought back, and this link can be tightened. And the most tight collaboration, what we should aim for in software engineering, is that industry and academia feel themselves as one team, where for sure challenges come from industry, research develops solutions, brings them back to practice, and this is done in several iterations, resulting also in publications and innovations in industry. So in order to achieve this goal, I provide results from several empirical studies, and these results can be grouped in 4 aspects that I want to present. First, common themes, then shared knowledge, joint patterns, and finally co-production. So let's start with common themes. So an important aspect that industry and academia can successfully collaborate is that they have a common theme of collaboration, right? This is not trivial, and I want to present this in the context of testing. We did an empirical study. You can see this. It was done in industry with 105 participants, and we asked the participants where in testing, in which part of testing they see challenges where academia can help. And here we can see the distribution. So in most areas there are no challenges, but especially in test management and in test automation there is a moderate distribution, from which we can see that industry thinks that academia can help, right? So we can see 30 high challenges where industry expects support from academia. So on the one hand, we need to take these topics into account, but there is another aspect, and this aspect is that industry and academia often mean different things with the same term. And a very good example here is test automation. So with test automation, we did another study where we analyzed titles of presentations given at industrial conferences and at academic conferences. In both areas, it were the leading ones. Overall, we collected around 350 titles. And we formed these word clouds from industry and from academia. And what you can see, the term automation, mobile, agile, quality, these are the most prominent terms in industry, whereas in academia it's more model, it's combinatorial, and it's even terms like mutation. So here we can see, if we dig deeper, that two different aspects of automation are covered. Yeah? In industry it's more the automation of test execution, whereas in academia it's the automation of test case design in terms of suitable test generation approaches. So there it's important that industry and academia are aware of different angles on the same area as well, yeah, and to make clear what the benefits are of studying each other's challenges. So I think industry is in most cases not aware of advanced modern test automation approaches like model-based testing or search-based testing, but could benefit a lot from this. So there it also needs to transfer this information in proper terms to practitioners. So let's move on to shared knowledge. I mean, we all know that industry and academia have different venues where they publish, and also different style of publishing, which is natural and makes sense. It doesn't make sense to fundamentally change this. But on the other hand, especially when collecting knowledge and analyzing it, then it makes sense to also consider the other area. And therefore we recently coined a literature analysis approach called gray literature studies or multivocal literature studies, where gray literature is taken into account. What is this about? Gray literature is an aspect that complements traditional white scientific literature, where there is known who was the expert that published something, where there was a rigor publication process, and also where there is outlet control. That means things that can only be published in conferences or journals. Yeah? And gray literature, and there are different shades of gray, are not that rigorously published, and the publication process is not that rigorous. An example may be white papers, but even blog posts or videos fall into this category. But if you look into what practitioners provide today, then these are mainly these outlets, right? For instance, also Stack Overflow, wiki pages, all these aspects. And therefore we developed a methodology to take these types of literature into account, and to also gather sources that would otherwise not be taken into account. An example study that we did is a gray literature review on test process models, and here you can see that there are some test process models that are only available in academia or in formal academic literature, like TPI Next. We only found it there. And on the other hand, there are models like TMAP, where we only found publications in the gray literature. So you can see, if you don't consider the other source, then you may lose relevant information. And furthermore, you can see that most test process models were published both in academic and in gray literature. So it makes sense to consider this aspect, and to also consider different channels for publication. This may be classical digital libraries where scientific literature is published, but also blogs or videos on YouTube, for instance, to provide information. Then one should also be aware that there are some patterns of collaboration. We did a study on that, and we found patterns and anti-patterns for industry-academia collaboration by asking practitioners and researchers that collaborate with industry. So we found the 5 most positive patterns for successful industry-academia collaborations that are working as a team and involving the right practitioners. then having mutual respect, understanding, and appreciation, then furthermore considering and understanding industry's needs and giving explicit industry benefits, and researchers on-site present and access, so not being only disconnected but really being there. There are many more patterns, but these are the most important ones highlighted by our study participants to provide successful industry-academia collaboration and success of projects. On the other hand, there are also anti-patterns that reduce the positive aspects, and the two most important ones are following a self-centric approach, so not really considering the other sides, and ignoring project, organizational, or product characteristics. So we can see most of these aspects really focus on soft aspects. Soft skills are very important, and this stems then for software engineering research in general, that you have to understand the industrial perspective and how to work with it, if there are also some researchers that listen to this talk. So finally, an important pattern is co-production, and here you can see my perspective on software engineering research that actually shows that the integration of industry, the co-production, is a core aspect that is fundamental. And how does this model work? I mean, software engineering research should always be driven by problems and data from an application domain. This can be life sciences, mobility, energy, finance, industry, production, but also domains like cybersecurity or artificial intelligence, right? Then software engineering tries to provide its software-based engineering approaches, producing programs, specifications, product or system-oriented approaches, methods and processes, or even human and organizational aspects that allow to develop software-based approaches in a solid way. However, software engineering as an engineering discipline needs basic research disciplines in order to answer its research questions. And the most important basic research underlying is for sure computer science, which for instance provides optimization approaches as in search-based software engineering. I mean, so the relationship between software engineering and computer science can be considered similar as the relationship between electrical engineering and physics, right? But in software engineering there are also other basic sciences that are important, especially also due to the human and organizational aspects of software engineering. These basic sciences are therefore also psychology, management, but for sure also technical sciences if you are more in IoT area, mathematics, or data science. These basic sciences provide theories and algorithms that are integrated into software engineering research results, which are provided then as artifacts that can be tools or as evidence what works best in what context to practice. Finally, there are even models which come more from innovation management and not so far from software engineering that actually foster industry academia co-production, to even see industry and academia collaborating in a co-working space to have a common problem, consider joint funding and resources, actively collaborate, and to provide new knowledge with a value for, on the one hand, researchers in terms of publications, practitioners in terms of improvements, but also value for society in creating something that is generalizable and applicable for other contexts as well. Yes, these were my reflections. On this slide you see the references I referred to, so please have a look or contact me in person if you're interested. For that purpose, you see here on the last slide my affiliation. It was my pleasure and honor to give this presentation, and stay safe and take care. All the best.